The universe is acting strange, a cosmic mystery that could change everything. There's something profoundly puzzling going on in the universe, something that has even the brightest minds in astronomy and physics scratching their heads. Recent discoveries made by the James Webb Space Telescope, JWST, one of humanity's most advanced scientific instruments, are revealing galaxies that seem to have existed before the Big Bang, a concept that challenges the very foundation of modern cosmology. The Big Bang theory has been the cornerstone of our understanding of the universe for nearly a century. It describes the origin of a universe as a singular explosive event about 13.8 billion years ago, from which all space, time, and matter expanded. But now, new data from JWST is shaking this long-standing framework to its core, leaving scientists with questions they have never faced before. Could it be that the Big Bang theory is incomplete? Or even fundamentally wrong? A forgotten pioneer, Fritz Zwicky, and the tired light hypothesis. Long before these questions resurfaced, a Swiss physicist named Fritz Zwicky had already proposed alternative explanations about how the universe might work. Zwicky, who was a contemporary of famous scientists like Albert Einstein, George Lemaitre, and Edwin Hubble, suggested an idea called tired light. While Einstein's theory of relativity established that the speed of light is a constant in the universe, a speed limit that nothing can exceed, Zwicky hypothesized that light could undergo a physical change or fatigue as it travels through the vastness of space over time. This means light might lose energy gradually during its journey, affecting how we perceive distances and the speed at which galaxies appear to be moving away from us. Though Zwicky's tired light theory was largely dismissed in the past, the new anomalies observed by JWST are bringing his ideas back into scientific discussion. The James Webb Space Telescope, peering deeper into time and space. The JWST, launched in late 2021, has opened a new window into the early universe. Its incredibly sensitive instruments, particularly its advanced red light spectrograph, allow it to see the faintest, most distant galaxies that existed over 13 billion years ago, a time so close to the Big Bang that it was previously thought galaxies couldn't have formed yet. Thanks to JWST's groundbreaking observations, astronomers have discovered several galaxies with ages that defy existing cosmological models. Glass Z13. Found by Harvard student Rohan Naidu and his team, this galaxy existed roughly 200 million years after the Big Bang, much earlier than expected. Its presence implies that galaxy formation began far sooner than current theories allow. GN-Z11, originally spotted by the Hubble telescope and later confirmed by JWST, GN-Z11 is one of the most distant known galaxies. At about 13.4 billion years old, it shows star formation occurring in the very young universe, contradicting previous models that suggested such complexity should have taken longer to develop. Source 93316. This galaxy is especially controversial because it appears to be as old as the Big Bang itself, roughly 13.8 billion years. If accurate, it challenges the idea that matter took time to clump into galaxies and suggests that our timeline of cosmic evolution might be completely off. HD1. Among the brightest and most luminous early galaxies discovered, HD1 shows a rapid and intense rate of star formation that scientists hadn't expected to see in such an ancient galaxy. MAX 0647 JD. Although not the oldest, this galaxy exists just 500 million years after the Big Bang, but is remarkably evolved, showing a high degree of structure and size. According to conventional cosmology, MAX 0647 JD should be several billion years older to exhibit these characteristics, again implying that our understanding of the universe's timeline may be flawed. These galaxies are just a fraction of the more than a dozen impossible galaxies detected by JWST so far, each posing questions that current cosmology struggles to answer. The cracks in the Big Bang theory. Are we misreading cosmic light? One of the core tools astronomers use to measure the universe is light. Specifically, the speed of light and how it changes or shifts, known as redshift, as it travels across the expanding cosmos. This redshift has been interpreted as evidence that the universe is expanding, which supports the Big Bang model. But what if this interpretation is incorrect? Zwicky's tired light theory suggests that the light we observe from distant galaxies might lose energy on its long journey, making objects appear farther away than they actually are. Even small discrepancies in how we understand light's behavior could translate into errors of millions of light years in distance measurements. Moreover, light emitted billions of years ago comes from stars and galaxies that may no longer exist in their original forms, meaning what JWST observes is not a snapshot of the present, but an echo from an almost incomprehensibly distant past. Since space itself has been expanding, this affects the light's wavelength, but exactly how is still debated. We can only observe the light that arrives here, not the light at its origin, which leaves a huge gap in our understanding. Revisiting cosmic constants. Could the universe be much older? In 2023, Canadian physicist Rendra Gupta proposed a radical theory, suggesting that small tweaks to the constants governing cosmic expansion could double or even triple the estimated age of the universe. According to Gupta's calculations, the universe could be as old as 26.7 billion years, nearly twice the current estimate. With further adjustments, the universe might even be 40 billion years old. This would explain why JWST is detecting galaxies that seem too old or too evolved for a 13.8 billion-year-old universe. Gupta's model also revisits Zwicky's tired light hypothesis, indicating that these older ages and the observed cosmic phenomena fit together in a coherent way, potentially forcing scientists to rewrite much of cosmology. The scientific community's reaction: excitement and skepticism. The response to these revelations has been mixed. Michio Kaku, the renowned American theoretical physicist and popular science communicator, embraces the new findings enthusiastically. Kaku has long believed that our current models are incomplete and welcomes the opportunity JWST provides to challenge and expand our understanding. He also points out that reconciling quantum physics with classical physics remains a major hurdle, another sign that current theories don't tell the whole story. On the other hand, John Mather, project leader of JWST and Nobel laureate, remains steadfast in supporting the Big Bang model. He argues that while galaxies may have formed faster than previously thought, the overall framework remains valid. Meanwhile, British mathematician and physicist Sir Roger Penrose offers a different perspective with his cyclical universe model. Penrose proposes that the universe undergoes endless cycles of birth and death, where the death of one universe seeds the birth of another. In this model, black holes play a crucial role as they eventually evaporate, releasing the information and matter that form the foundation of the next cosmic cycle. This idea could explain the rapid formation of stars and galaxies seen by JWST as remnants of previous universes carried over into the new one. Penrose's model even aligns with new research from 2023, suggesting our universe itself could have originated from the interior of a black hole in a parent universe, a mind-bending notion that continues to spark debate. What does this mean for our understanding of reality? These discoveries and theories suggest we may be on the verge of a scientific revolution in cosmology, comparable to when Copernicus first proposed the heliocentric solar system, or when Einstein redefined gravity. If the Big Bang Theory is incomplete or flawed, we will need to rethink the origin and age of the universe, re-examine fundamental cosmic constants and the nature of light, explore new models like tired light, cyclical universes, and multiverse theories, integrate quantum physics and gravity more coherently. All of this highlights the humbling reality that despite centuries of scientific progress, the universe still holds many secrets. And with each new technological breakthrough, like JWST, we get closer to unveiling them. Looking forward, the future of cosmology. As JWST continues to collect data, astronomers expect even more surprises and discoveries that will either reinforce or challenge our current understanding. The key will be to remain open-minded, willing to question long-held beliefs, and to embrace new theories that better explain the data, however strange they may seem. By combining observations, theoretical physics, and computational models, we can hope to unravel the profound mystery of the cosmos and perhaps discover not only how the universe began, or if it even began at all, but what its ultimate fate might be. If you're fascinated by these groundbreaking discoveries and want to stay updated on the latest cosmic revelations, be sure to subscribe and join the journey into the unknown frontiers of space and time.